we start to non-dimensionalize the equation. We are going to perform the non-dimensionalization still with respect to the external velocity. That's one of the obvious non-dimensionalization out there. So let's set my u, big U this time, the non-dimensional u, to be small u divided by ue, the velocity relative to the external velocity profile. And then we know that the length scale in the y direction develops as I advance downstream, right? So we are going to set a certain length scale, let's say delta, being a function of x. In the similarity solutions, we know if we have Blasius, delta x grows like square root of x. That's a length scale in the y direction. In the other Faulkner-Scan equations, delta x grows to some other polynomial, maybe slower than half, maybe greater than half, a certain polynomial power law of x. So in here, let's not decide what kind of growth it is. We just said, okay, let's say we have an arbitrary delta as a function of x, and try to see if there is something that comes out of the non-dimensionalization process. All right. So with a velocity scale, a length scale, let's now non-dimensionalize phi. Phi is the integral of u. So the dimension of phi is actually the dimension of u times the dimension of the length scale, right? So let's non-dimensionalize phi with respect to the product of the dimension of velocity ue and the length scale we have to be delta. And let's keep in mind it's a function of x. Right? So with these two, let's start to, okay, so the delta x is used to non-dimensionalize y into our unit eta. So eta is defined as y divided by delta of x. And let's keep the x direction to be as it is, and let's just define c to be exactly equal to x. Yes?
In this case, is UE also a function of x?
UE is also a function of x. Exactly, right. So let's write that down so that we don't forget.